Hello. Earthquake risk models were developed to help us answer key questions about the risk. When will the earthquake occur? How big will the earthquake be? How bad will the shaking be at my property location? And how much damage will my property occur? Now, while these are the right questions, the answers are more complex, and it requires a greater decomposition of this thing we call risk into the key components. Our growing scientific understanding of earthquake risk has led us to segregating earthquake risk into discrete components. The basic components of an earthquake risk model start with the source zone characterization. It tells us maximum magnitudes, how the earthquakes, the rupture mechanics involved in that earthquake, and how often it occurs. The second component is how the ground motion attenuates with distance through the Earth's crust to the location of your property. These are known as GMPE, or ground motion prediction equations. The third key aspect is the vulnerability. It translates the ground motion at a location to actual damage. Now, these components are not independent, and they interact with each other, and they need to be validated together. But segregating them allows us to really understand the risk further. Seismic source zonation is an area of science that's rapidly improving. At its most simple level, it helps us differentiate the type of ground motions we get from the great subduction events that we see in the Pacific Northwest or off Japan or down in Chile versus the strike slip events that are more common in California, Italy, and Turkey, and many other areas. The improvements in this modeling for seismic sources helps us better understand aspects like aftershocks, which were extremely consequential after the New Zealand earthquakes, or maximum magnitude understanding, as we struggled after the Tohoku with our understanding of what is the maximum magnitude. The seismic source characterization is very important in being able to help us understand the frequency and severity of the greatest earthquakes. Ground motion prediction equations, or GMPE, inform us as to the intensity of ground motions at a site during an earthquake. They are aligned with the source characterization models because the different types of earthquakes rupture differently and produce different ground motions at a site, even with the same magnitude. The latest GMPE provide us insights into the shaking intensity for different types of structures, using different parameters such as peak ground acceleration, or PGA, peak ground velocity as PGV, or spectral acceleration at specific recurrence periods, intervals, which are really important because different types of buildings respond differently at with the same shaking. Vulnerability modeling describes the translation of ground motions at a site to monetize form of damage for input into financial models of your catastrophe model. Historically, there have been three ways to develop vulnerability models: looking at historic claims data, relying upon experts, and usage of analytic models, dynamic models such as are used for building design. All three methods are valid, and they combine to create a much better picture of how damage is expressed.